So today we are going to discuss cloud computing. So cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. So that is the most important thing is pay-as-you-go by pricing. That means whenever we will require to uh, have some resources to be borrowed, that will be that means on demand. On the demand basis, we will be using the resources that cloud computing infrastructure we can consider. So basically, instead of buying the whole on-premise, or instead of buying or owning and maintaining the physical data centers, servers, we can access technology services such as computing power, storage, databases, and many other services whenever we are in need basis from a cloud provider like Amazon Web Services, and then Google Cloud Provider, and then Microsoft Cloud, and all this. So that concept is called cloud computing. Basically, it is a on-demand delivery of IT resources. So there are various service providers of clouds are available, such as Amazon Web Services, AWS, which is most popular, and which is one of the dominating player in the market, cloud market. So it is around 40% of the overall cloud infrastructure that is available in are dominated by AWS, by the Amazon company, and then remaining percentage are also like there are also dominating players such as Microsoft Azure, Google Cloud, Alibaba Cloud, Oracle, IBM, Salesforce, SAP. These are also popular cloud provider. So majorly it is Amazon Web Service which occupy 40% of the overall market. So what is cloud computing? So cloud computing is basically a metaphor for supply and consumption of IT resources. So cloud computing can be metaphorically understood as a supply and the consumption of IT resources, much like how we use electricity. So the supply side, we can have this uh, supply side. We can consider like what are the services can be supplied, such as computing power, power, then storage. So these are the mainly two things that any company in the initial stage would be requiring. One is computing power, and another one is storage, and then software via internet. Some software also you may be requiring. So these things are being supplied. And in the consumption side, I mean, what to say, like in consumption side is like using electricity. So cloud computing consumption is bit like electricity, the way we use electricity. So we basically use it whenever we require it. So that is the thing. Okay. This is the first point. Second point is that um, so you understood this is basically the resource of computing power and resource of storage. These are the two major resources that cloud computing provides. Apart from that, it also can provide networking services, and then security also it has to take care. Otherwise, if we put any data on the cloud, our data should be secure enough. So security also an important aspects of cloud computing. Okay. Next is to implement or to access cloud computing, we need one important software, and that is called software layer, that is called virtualization, or the machine will be called virtual machine, which is a software basically. So varies from virtual machines to software as a service. So first you have to understand what is virtualization. Okay, virtualization you have to understand. So first concept through which the first software, or you can say that, yeah, software layer application through which you will be accessing the cloud computing infrastructure is called virtualization. Okay, So through virtualization only we have to access these services of cloud. So how this virtualization look like is so basically if you see so this is the, let's say, a cloud infrastructure where we have computing powers and storage majorly. So let's say this is the physical layer. So basically in the service provided like Amazon Web Service or Google, they'll be having the physical servers at their end, and from that physical servers and racks and data centers, from that some physical servers will be there, physical devices will be there. So mainly it is computation, let's say, and then it is RAM, okay, and the RAM, access of RAM also you might require, and then you have this network connections, okay, these three. So physically they will be there somewhere in the service provider, service providers, they will be having this physical computation and physical server, physical RAM, networks, everything, okay, and also maybe storage also may be there. So storage, so this is let's say processing power. That processing power you need to be accessed through cloud, and then short-term storage also you might be required, short-term storage, okay, which is nothing but RAM, and then networks also you might be requiring to access. So the layers, that is the concept, the layers, that is software layer that is helping to access this is called hypervisor, okay. So this hypervisor terminology is very important, hypervisor. So through this hypervisor, any user can access this processing as well as this RAM, networks, everything, storage through hypervisor. So storage directly hypervisor is not involved, but network, RAM and other services, computation services, is hypervisor is responsible, okay. So hypervisor can virtualize. So basically for the virtualization, so hypervisor can virtualize even this one CPU. Let's say this is CPU, and it can virtualize RAM, it can virtualize network. So whenever it is virtualization of and it can virtualize even servers. So server virtualization will be called. If storage is getting virtualized, storage virtualization will be called, and when network is getting virtualized, we will call network virtualization, okay. So the responsible layer that virtualizes all these functions is called software layer, you can call, is called hypervisor, okay. So basically virtualization is used to create virtual version of an underlying service, okay. That is what virtualization does. It virtualizes the underlying service. So you can write it here. So virtualization, virtualization used to create virtual version of underlying service, okay. So here underlying service could be CPU, underlying service could be RAM, and that has to happen using hypervisor. So with the help of the virtualization, multiple operating systems. So this whole thing you can consider as a host OS. Let's say this is a host OS, okay, host operating system, and this is server hardware, you can call server hardware, okay, hardware. This whole thing, this processing, RAM and network, this is server hardware, and this is host operating system. So with the help of the virtualization, multiple operating systems and applications can run on the same machine, and the hardware at the same time, increasing the utilization and flexibility of the hardware. So by this process, using hypervisor, you can even utilize it of your own limits, okay, and flexibility of hardware and everything is there. It was developed during the mainframe era. So this virtualization concept or virtualization technique is developed using mainframe era. So what are the benefits of virtualization? Because you are virtualizing CPU, RAM and all this. Benefits as it is cost effective, is cost effective. Then you have is no hardware reducing, and then you have energy saving. Carbon footprint will be less, energy saving. Okay, these things are there, virtualization benefits. So if you virtualize CPU, it can virtualize RAM, it can virtualize network, everything. Okay, so now what happens on the top of the virtualization, we have virtual servers. So let's say this is virtual server 1, this is virtual server 2, and like that we can have n number of virtual server n. Okay, we can have n number of virtual servers, and you can access each virtual servers, and then that virtual server using hypervisor can access this hardware computation. I mean the physically the servers and everything is there at the cloud provider side, I mean data centers and all this. So that can be accessed using virtual servers. So let's say here user is there, user is accessing this, and then somebody may access CPU, somebody may access, so this fellow can access maybe computation processing, this fellow can access RAM using virtualization concept, and so all things are possible. And network also, somebody wants to, some user may access. So the question may arise that whether these virtual servers, because they are somewhat attached, whether they share the data or not. They are in isolation, so your data is safe. So virtual server data here will be safe, the virtual server data will be safe, so there is isolation, no problem. Okay, so this is there. Now another important thing is that hypervisor is of two type. Hypervisor is of two type. One is the type 1 hypervisor, and another is type 2. Type 1 hypervisor and type 2 hypervisor. Okay, so you can write it like this, type 2. So type 1 hypervisor has direct connection with the physical computer hardware. So it can be bare metal, you can call it bare metal hypervisor. Bare metal hypervisor, it runs directly on the computer hardware, whereas it has operating system capability and highly efficient, as it is directly access the physical resources. So direct connection with the physical resources. So that means type 1 hypervisor runs fast. Okay, because it has direct connection with the physical resources, whereas type 2 hypervisor runs as an application, runs as an applications on computer hardware with an existing OS, on computer hardware with existing OS. Okay, so this is the difference between type 1 and type 2 hypervisor. Okay, so and then you have this when you virtualize this network, so it can be done. I mean, network virtualization could have it has two way you can virtualize network function virtualization. So it can be virtualized in two way. One is called network function virtualization, and another one is called network software defined networking. So this is number 1, and number 2 is software defined networking. Okay, software defined networking. So in case of network function virtualization, here it combines the function of network appliances such as firewall, load balancer, traffic analyzer. Okay, so this is like, if I write it here, firewall, then load balancer, firewall, load balancers, it combines everything together, and then traffic analyzer. Okay, whereas whereas this software defined networking, which in short called SDN, software defined networking, it controls the traffic routing by taking over routing management from data routing in the physical environment. This software defined networking, SDN, so it controls the traffic routing by taking over routing management. Okay, so this is there. Now you can see this is another important thing is that, which is called application virtualization. Okay, application virtualization is another concept. Application, and then you can virtualize data also. So if you virtualize, you can virtualize server, you can virtualize storage, you can virtualize network. Network virtualization can be done in two ways: network function virtualization and software defined virtualization. So you can write it network function virtualization and software defined networking. Two ways. Third one, you can virtualize even data, which will be called data virtualization. So all these things could be virtualized. Okay, and then there is another concept which is called application virtualization. Application virtualization. So application virtualization, it pulls out the functions of applications to run an operating system other than the OS for which they were designed. So basically, example wise, we can say that user can run Microsoft. So application user can run Microsoft. User can run Microsoft Windows application. Microsoft Windows applications on a Linux machine. Okay, without changing the machine configuration. Okay, so what are the application of application virtualization? First one is application streaming. Second one is server based application virtualization. Third one is local application virtualization. Okay, so this is called application virtualization. Okay, now this is the cloud computing metaphor. The metaphor is that a group of network elements providing services does not need to be addressed or managed. So the user is not bothered about the underlying technology, underlying complexity of the resources that it is using. The cloud service provider will take care of the complexity. So that is the cloud computing benefits. Using cloud computing, that is the benefit. And so 5 essential characteristics of cloud. 6 important advantages of cloud computing is that it is global in minutes. So whenever you have application, it is immediately going global on the web. Second thing is that stop guessing capacity. You should not bother with the capacity because it is like auto scaling. The capacity is auto scaling. You can use as much as you want. Focus is on the business differentiation rather than focusing on, earlier it was on premise, right? So on premise means on premises and then cloud. This is the basic difference. So on premise means you have your own things and the maintenance will be difficult. A cloud means you are borrowing from the cloud provider. So on premise, earlier you were bothered about your own infrastructure, how to spend, how much I should have the processing power, what about the storage, how much cost it will be coming, all these things on premise. In short, it is called on prem. on-prem. Okay, but now once cloud you have, you can focus rather than this all unwanted thing. You can directly focus on business differentiation and the decisions. Second, you have economy of scale, and then variable versus capital expenses. That means earlier when on-premise stuff was happening, your capital expenses was more. Now it is variable expense demand. As per the demand, you will be using it, and then increasing the speed and agility. Everything is enhanced now once you use this cloud infrastructure. So these are the six advantages of cloud computing. So the cloud development deployment model, there are three models. One is public cloud, private cloud, and hybrid cloud. So example of public cloud, public cloud is managed by an organization open to the public. Private cloud is IT infrastructure for a single organization. Hybrid cloud is combination of on-premises data center and public cloud. So there are three cloud service model. One is infrastructure as service. These things we'll study further in detail. So infrastructure as a service, if you are borrowing like computing, storage, networking, etc., Amazon EC2, Google Computing Engine, that will be called IaaS. Platform as a service if you use, which is called capital PaaS, which is a platform to deploy custom applications such as AWS, Lambda, Google App Engine. And then finally, your software as a services, infrastructure and software running in the cloud, such as Amazon Workspace, Google Workspace. Okay, so these three service model: infrastructure as a service, platform as a service, and software as a service. So when infrastructure as a service was there, it was more control over IT resources. When software as a service, less control of the over IT resources. So this is private cloud and public cloud. You can see private cloud and public cloud merged together. It will be called hybrid. So private cloud basically used in the on-premises, and then public cloud is global. So okay, so I hope you understood the basic of cloud computing and the terminology that are associated with cloud computing. I hope you understood that. Thank you.